nothing. Not literally. And the little subheading under that is graphing them. And let's see what it says. We'll write down this is the definition from the book. A function is a rule, or I guess you could call it a formula, that pairs one output number once we get an example here, with each input number. With each input number. I'll give you a chance to write that, and then we'll talk a little bit about that. A lot of times the book talks about it like a function machine. Remember this?
Yeah.
Where you stick an input number in there. Something happens to it while it goes in the little machine. Let's say it is, well, let's do this. 4S. That doesn't look like an S. 4S. And then out comes an output number. And quite simply, this is, a lot of times we make a table of this. So here would be the goal. First of all, the formula would be this. Let's say we were talking about how to find the perimeter of a square. Usually we use y and x's. I'm not sure why, but that's just the way it is. If you're looking for the perimeter of a square, I guess we could use the letter B. Let's do it. The perimeter, gosh, that doesn't look very good. What color shall I use, children? Let's go black. Perimeter equals 4 times S. Now, if you're looking for the perimeter of the square, which letter do you suppose is the input number? You think you'd put the perimeter in and find out the side, or you think you put how long the side is and put it, and you'll get the perimeter? Which one do you think is more logical? Side, right. So the first one given, this is our input number. The perimeter is what you're going to get out. That is your output number. Okay? And again, you can put any number you want in that whole thing. You know, let's say if the square has a side of 1, I put 1 in, I multiply it by 4, I get the perimeter, which is just 4. If I put 3 in as my input number, what's going to be my output? Wow, look at you, you guys are faster than. And if I put 6 in, 24. Okay, got that? Now these, just a couple other names that the book gives these that you'll hear for the rest of your mathematical life. The input numbers are also known as AKA. They're called the domain numbers. Just write that. You don't really have to understand much about it. And the output numbers are called the range. The domain and the range. Now, because, children, because you could put any number you want into that whole little thing. I could pick 20, I could pick 30, I could pick 7, I could put, I don't know if I could really put negative numbers in there. Because I do that, one way we show the answers to functions is we graph it. Because a graph will really show us all the answers. And graphing it is very easy because right here, each one of these is an ordered pair that you can graph. For example, 1, 4 is the ordered pair 1, 4. That's one point on my graph. Another point is 3, 12. 312. A third point would be 624. Okay, which means if I have a graph, let's say I've got a coordinate system. If I plot points at 1, 4, here's 1, 1, 2, 3, 4, 312, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What if I put, let me put 0 in there so I don't have, if I put 0 into this little function machine here, what do I get? Square that has a side of 0 has what as a parameter? 0. So then once I have my little dots there, you connect the dots just like when you or whatever. And this little line here, it should be a straight line. This line is all answers to your function. It's all the answers. Now, if I would have 4 here, it would go up to 16 up here and cross at 16. If I had 5 here, it would go up to 20. This is how we show, because there are infinite amount of answers. One way you show it is you graph it and it becomes a straight line. It is forever out. What else does I have there? And then I need you to take out one more piece of paper. And on top of that piece of paper, write, well, let's write, yeah, let's just write proportional. And again, a lot of this is just introductory stuff, so if you don't quite get it, don't worry, it'll come back again and again. It's a little like your ABCs, children. You didn't learn them the first time, your parents introduced them to you. You got a little better each time you saw it. That's what this will be just like. So why can't I go with a different color line? In math, we talk about things being proportional. And when we talk about things being proportional, it means that things go up at the same, kind of like at a steady rate. Something doesn't go really fast and then slow down and goes up. For something to be proportional, 2 things have to happen. Number 1, it must be a straight line. And number 2 is the big one. It must go through the origin, which means this. It has to go through here and be a straight line. Those 2 things have to happen. This is proportional. The book calls it a direct proportion. This one, while it's a straight line, doesn't go through the origin, so this is not proportional. Something that would be proportional would be, let's say you got a job making, well, I guess $15 an hour is minimum wage pretty soon. You know, y equals $15 times x. X would be the number of hours you work. Is that proportional? Well, let's see. First of all, does it go through the origin? If I put 0 in for x, do I get 0 for y? 15 times 0, what is that? 0. If I put 1 in for x, I make $15. If I work 1 hour, I make $15. If I make 3 hours, I make $45. Why did I pick such high numbers? If I put 2, I make $30. if you graph this graph, make this a graph of your salary, will it go through the origin and will it be a straight line? Now, it definitely goes through the origin because this is 0.00. And 115, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 230, right up here, it definitely is a straight line. So this is a proportion. Just remember those two things. Straight line through the origin. One more just for fun. What if my equation was y equals x plus 2? Remember graphing this? I get to pick my x numbers. What numbers can I pick? Let me give me 3 numbers. 3 numbers for x. Make them easy. 3,
4,
2,
1,
4.
8.
If I take 3 and add 2 to it, I get 5, right? 2 plus 2 is 4. 4 plus 2 is 6. If I graph those points, 3, 5, 1, 2, 3, 1, 2, 3, 4, 5 is a point right there. 2, 4, 2, 1, 2, 3, 4. 4, 6, 4, 1, 2, 3, 4, 5, 6. Like this. There's my graph of that line. Is that a proportion? Say what? Why is it not? Okay. Because it doesn't go through the origin. So this is not proportional. The other thing you can think about is this. If something is proportional, it has what we call a constant of proportionality. Check this out, Riv. This will throw your friends. That means this. In order for things to be proportional, whatever you multiply this by to get this, you have to multiply everything by to get that. Which we don't know. 3 times 1 is 5, it doesn't matter, but you know, 4 times 1.5 is that. It doesn't matter. And it won't work for this. Well, here, this is a good one. How do I go from 2 to 4? I multiply by 2. For this to be proportional, every one of these should be multiplied by 2. In other words, 3 times 2 should give me 6, and 4 times 2 should give me 8. If that was the case, this would be a proportional, but it is not. Go back to our table here. What did I multiply everything by? 15. 0 times 15, 1 times 15, 3 times 15, 2 times 15. So it is, the constant of proportionality is 15 because you multiply by 15. That's enough of that. What was that?